Today we're going to be talking about the graphs of polar equations, of some polar equations. I will tell you that polar functions make some awesome graphs, okay? Today we're going to be talking about three of them, or actually just two of them, circles and roses today, okay? And tomorrow we're going to be looking at cardioids and limacons, but know that there are a lot more. We just talk about a few in this class. We call these the classic polar functions, but they are just a few of some very interesting polar curves. And on your calculator, if you hit mode, you can come down here and go to polar mode. And when you do that and hit enter, then when you go to y equals, you're no longer going to see a y equals, you're going to see an r equals. So R1, R2, I already have some in there. Let's clear those out like that. Okay. I like to, when I'm graphing polars, I like to see how they're graphed. And so this little, if you hit enter until you see that little icon, it allows us to see these polar graphs more clearly as they're graphing. Anyway, I like that. It's not absolutely necessary, but whatever. I do like that. Okay, so we will be doing a few things on our calculator, but this will all be, when you're doing your homework, it'll be no calculator. So you cannot use your calculator. You need to use your head for these. So we're going to be looking at patterns. So we can use our calculator to explore, but otherwise, know that you're going to be responsible for doing this without a calculator. Okay? Alrighty, let's first talk about circles. Okay, there are two types of circles. Circles centered at the origin and circles centered on one of the axes. These are circles that we're going to deal with. Of course, there are lots of other circles, but the ones that we're going to be talking about in this class are circles centered at the origin and circles centered on one of the axes. Okay? More precise, circles centered on one of the axes, but the circle is still going to go through the origin. Okay? All right, but first, circles centered at the origin. They have the form r is equal to some number. Okay? So when r is equal to just a number, the circle is centered at the origin and the radius is the absolute value of a. So if you were graphing r is equal to 2, it would be a circle centered at the origin, and everywhere you go would be 2. 2 right, 2 left, 2 up, 2 down, 2 sideways, 2 whatever. All the way around is 2. To graph r is equal to -1, we're still centered at the origin. The radius is still 1 all the way around. Okay? So that negative does not make an impact on the resulting graph. It would make an impact on the way it is graphed, however. So those are the resulting graphs. Let's go explore for a moment on our calculator. If I was graphing r is equal to 2, there's the way it is graphed. Okay. If I was graphing r is equal to -1, there's the way it is graphed. So you see it starts in a different location and it goes in a different, well, it goes in the same direction. Okay? Alrighty. So we will be doing some exploring here, but we're going to be doing everything by hand. Okay? Alright. Circle on one of the axes. Alright. If you have r is equal to a number times cosine of theta, a number times cosine of theta, here's my thought. It's a cosine, so it's x-axis positioned. If it's a cosine, it's x-axis. If it's a sine, it's y-axis. All right? So it's a cosine, so x-axis. Okay? If this number is positive, then it will be on the positive x-axis. If that a is negative, it will be on the negative x-axis. Same thing for y. So if there is if you have a sine, then you have a y-axis position. Okay? If the first number here is, if the coefficient is positive, you'll be up on the positive y-axis. If the coefficient is negative, you'll be down on the negative y-axis. Okay? So let's graph these. R is equal to 3 cosine theta. Well, it's a positive and it's a cosine. So I know I'm on the positive x-axis. Okay? So I know I'm over here on the positive x-axis, and I know that my diameter is 3. So from the origin out is 3 units. That's 3 units. It goes through the origin and it goes through that point there. So there's my circle. Okay? R is equal to -4 cosine theta. So -4 cosine theta, I know I'm on the negative x-axis, and I'm going to go out 4 units. So I have a point there, and I have a point here that is at 4, and then I draw my circle like that. So looks a little egg-shaped, but that's okay. So it's a circle of diameter 4. Okay? 3 sine theta. So it's a positive sine, so I'm up on the positive y-axis. And I have a diameter of 3. So this is 3. Negative sine, so negative y-axis. The diameter is 2. Okay? And that's how you graph circles. Those are all the circles, either centered on an axis or centered at the origin. You need to be able to recognize this. So when you see an equation like that, you know it has to be a circle. We're going to get more and more equations. So let's keep these all straight. What is true about each of these? Well, it's just a single term, a number out in front, a number coefficient, either a sine or a cosine, and only theta here. Only 1 theta, not 2 theta, 3 theta, 4 theta, all of that. Okay? So that's how you distinguish a circle equation from a not circle equation. Okay? Our next type are the roses. Okay? The roses will look like these. Okay? So let's look at those equations. So it starts out looking very much like a circle, except it's not just a plain theta. The theta has a coefficient other than 1. Okay? Alrighty. So here's how you graph a rose. Okay? So they call them roses. To me they look more like daisies, but they don't call them daisies. They call them roses. I don't know why. So first of all, we have the number of petals, or you can call them loops or petals, I don't care, but the number of petals. Okay? This number will determine how many petals you have. If this theta coefficient, if that theta coefficient is odd, then you have that many petals. If n is odd, you have n petals. If, however, n is even, then you're going to have twice that many petals. Okay? So, there you go. That's how to tell how many petals you have. Alright? So, what if you have cosine roses? For cosine roses, here's my thought. If it's a cosine, I know I'm going to have a petal on the x-axis because cosine and x go together. Always think of that. Cosine and x go together. Okay? So, in this one, I have r is equal to 3 cosine of 2 theta. Well, first of all, there's a 2 theta there. So I have, 2 is even, so I have double that many petals. So I know I'm going to have 4 petals. I know each petal is of length 3. Each petal has that length. Okay? And it's a cosine. So since it's a cosine, I know that I'm going to have a petal on the positive, I start with the positive x-axis. Positive 3, positive x-axis for cosine. And now I need a total of 4 petals. They need to be evenly distributed around the graph. They're not like all going to be in the first quadrant. Okay? They're going to be evenly distributed. So I'm going to have one here, and one here. Okay? That's the graph of this one. Let's confirm on our calculator. Okay, 3 cosine of 2 theta. By the way, when you hit X, when you hit the X button here, you get theta now. All right? So let's go and graph this. I never get tired of watching these things graph. So that is the graph of 3 cosine 2 theta. And you see that each petal has length 3. Okay? Notice one thing about this, the way it graphs, it's very smooth. It's very smooth the way it graphs. Lots of times when I make the petals, I'm not so smooth. I'll do a petal here, and then I'll do a petal here, and here, and here. It's not one continuous motion. But when these actually graph, it is one continuous motion. No jumps. Okay? Everything is nice and smooth. Okay? Let's do another one. All right. 4 petals still. Another cosine, so I know I'm the x-axis. I have a negative 3. So in my mind, I'm thinking 1 petal on the negative x-axis, but I still am going to have 3 more petals evenly distributed. So I'm thinking that it's going to be awfully similar to the other graph. What happens if we now come here and make a negative 3 cosine of 2 theta? And sure enough, it is the exact same resulting graph. Now, the way it graphed, the order that it graphed was different, but the resulting graph is identical. Okay? Okay? 4 theta. Well, for 4 theta, I'm going to have an 8-petaled flower. Okay? Each petal is of length 5, and I'm going to have a petal on the positive x-axis. So I'm going to put my petal here. Now I need to evenly distribute the remaining 7 petals. So think of how you can distribute 8 petals with 1 petal being here. So I'm going to have one here, here, and here, and then I'm going to have one out in the middle of these quadrants. Oh, each petal should be each petal should be the same length. Clearly my drawing is lacking, but each petal is the same length here. And by the way, we should be denoting how far these petals go. So these were 3 and 3. This one is 5. Okay, so yeah, there is that. Let's see what this looks like on here. I'm going to get rid of this one, get rid of this one. 5 cosine of 4 theta. Let's see what it's supposed to look like. Nice and smooth. Okay? So that's how it looks like, really. Okay. It's a little embarrassing right next to the right one. Oh well, that's okay. Okay, what about 6 theta? This should be fun. 6 theta. So for 6 theta, we're going to have 12 petals. It's another cosine. Each petal will have length 4. I don't really worry about that. I just add that at the end, okay? All right, so 12 petals. But I do know there is going to be one on the x-axis. Since it's a cosine, I know there's going to be one on the x-axis. Okay? Alrighty. So 12 petals. Let's see. How are we going to do this? There's going to be one on every axis. So that's 4. So I need to add 2 more inside each quadrant. So 1, 2, 1, 2, 1, 2, 1, 2. Is that 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12. And each petal has length 4. We can confirm real quick. 4 cosine 6 theta. And sure enough, that's exactly what it does. Okay? By the way, in my window, I'm going from 0 to 2 pi. Okay? Alrighty. Now, we do notice, let's see. Okay. If n is odd, and you have a cosine, then you have 1 petal and 1 petal only on the x-axis. Okay? Go ahead and make your petal. Draw your first petal and then distribute the other ones around. So for this one, so if n is odd, we have that many petals, so 3 petals. Each petal has length 3 in this case. It's a cosine, and this is a positive 3, so I draw 1 petal right here on the positive x-axis. Okay? I need to add 2 more petals, and I want them to be distributed evenly on the circle. So it's going to look like this. Something like that. Let's confirm. 3 cosine 3 theta. So see, nice and smooth. Now do you see how my graph is going over itself? That just means that I didn't need to go all the way to 2 pi. I could have stopped at pi. But that's that graph. Okay, what about negative 3 cosine 5 theta? 5 theta, so 5 petals. And by the way, I should say that each of these is length 3. Okay, negative 3, so I'm going to draw 1 petal on the negative x-axis. So 1 petal on the negative x-axis, and that length is 3. Okay, now I need to do 4 more petals, 5 petals total. So think of how that would be distributed. I'm going to have, let me try to do this. I think I'll probably look like this. Oh, that's probably not exactly right, but let's go see how close I got. So negative 3 cosine 5 theta. And again, it's going over itself because I don't need to go all the way to 2 pi. Okay, not too bad. Alrighty. Okay, what about negative 5 cosine 3 theta? It's another 3 theta. So I know I have 3 petals. This time it's a negative 5, still cosine. So negative 5, so negative x-axis. Okay, and this will be of length 5. 3 petals. So sometimes I find it easier to do the smooth motions. Something like that. So look at how those compare. One was a positive 3 and one was a negative 5. Okay, 7 theta. For 7 theta, we're going to have 7 petals. Cosine with a positive number, so 1 petal on the positive x-axis, and that's a 4, so this will be of length 4. Okay, I need 6 more petals evenly distributed. This might be a little tough. I think I'm going to have like a petal maybe here and here. Maybe something like that. Maybe something like that, possibly. 4 cosine 7 theta. Close enough. Okay? All right. Let's write an equation for each graph below. Okay. So I see it's a flower. I see it's a rose. Okay? Now, I notice here on this rose that I have a petal on the positive x-axis. There are 3 petals. 3 petals, so I know it's going to be a 3 theta. Okay? Okay? Also, a petal on the x-axis, so I know it's going to be a cosine, since a petal is on the x-axis. Okay? And what number goes in front? Well, each petal has length 3. The petal is on the positive cosine axis, so it's a positive 3, and I finish it up with r equals. It's an equation, so it has to have r equals. So make sure you get the r equals in there. Okay? What about this one? Okay, well, it's a flower with 4 petals. 4 petals. So I know I need a 2 theta because 2 will double to 4. Okay? Now, petal on the x-axis. So I know it has to be a cosine. Each petal has length 4, so I know there's a 4 out front. Okay? And for even petals, it doesn't matter if it's a positive 4 or a negative 4. Both would yield the same graph. So there's that. Now you might be thinking, there's also petals on the y-axis. Why is this not a sine? We're going to get there in a moment, okay? But if there's a petal on the x-axis, it's a cosine. All right? Okay, let's do the next one. How many petals are there? 1, 2, 3, 4, 5, 6, 7. So 7 theta. X-axis, negative x-axis. So I'm going to have a negative 1, 2, 3 cosine theta. R equals to make it an equation. Don't just write that. Make it R equals that. Otherwise, it's not an equation. Okay. How many petals? 1, 2. First of all, you guys, I see that there are petals on every axis. Every axis. So I know it's going to be an even number. Okay? So let's go ahead and count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 petals, so 8 theta. It's going to be a cosine because we're on the x-axis. You don't have to put parentheses here, or you can. Either way is fine. Sometimes I do, sometimes I don't. Each petal has length 1, 2, 3, 4. R equals. Okay? All right, let's talk about sine roses. Sine roses are a little bit more complicated. Sine roses, first of all, if n is even. If n is even, you still have double that many petals, right? But if it's a sine and n is even, you are not on any axis whatsoever. Just like with cosine, if we were even, we were on every axis. But with sine, don't go to that y-axis, all right? Not if n is even, not if n is an even number. So here's how I would graph this. I see a 2 theta, so I know I have 4 petals. Okay? It's a sine with an even number of petals, so I know I'm not on any axis. I position those 4 petals in the middle of my quadrants. So it'll look something like this. Where each petal has length 3. That's how I denote that. Each petal has length 3. Okay? 4 petals. Okay, sine, so no axis. The -3 here will not make a difference at all in our resulting graph. It'll make a difference in where we start and the way it graphs, but not in our resulting graphs. So I'll just go ahead and draw my rows like that. Each petal has length 3. So let's see the difference in those. Okay, so 3 sine of 2 theta does this. Okay, looks like a butterfly, doesn't it? And then -3 sine of 2 theta, it just starts at a different location, goes in a different direction. Okay, same resulting graph. Okay, for 4 theta, well, 4 theta means 8 petals. It's a sine, so no axes, each petal has length 5. So 8 petals. See how we can do this. So 1, 2, oh gosh, 3, 4, 5, 6, 7, 8, maybe something like that. Each petal has length 5. Okay, so 5 sine of 4 theta. So there's that rose flower. Okay. All right, for a 6 theta, we'll need 12 petals. It's a sine, so no axes. So I'm going to have, since there are 4 quadrants, I'm going to have 3 petals in each quadrant. And I think I'm just going to draw it like this time. You're not going to be graded on your artistic abilities. Some people are like, oh. Some people are like, thank goodness. Okay, so 4 sine of 6 theta would look like that. Okay, just a little bit better than mine. Okay, what if that n is odd and you have a sine? Well, if n is odd and you have a sine, then yes, you do have 1 petal on the y-axis. However, placement of that 1 petal gets tricky with sine roses. Here's the pattern. If n is 1, you go up on the positive y-axis. If n is a 3, you have a petal on the negative y-axis. If n is a 5, you have a petal on the positive y-axis. If n is 7, negative y-axis. If n is 9, positive y-axis, etc. It flip-flops. Now that is if you have a positive coefficient. If you have a negative coefficient, that will all flip, right? So, you're not going to be responsible for graphing sine roses with an odd number of petals. You will need to know how to graph sine roses with even number of petals, but not sine roses with an odd number of petals. Okay? You will need to be able to answer this kind of multiple choice question though. Okay. If I see this, which could be the equation? All right. Well, first of all, I see 5 petals. So it has to be either C or D. It can't be 3 theta. It has to be one of these. Okay? Is it a cosine or is it a sine? Cosine would have to be on the x-axis. This is not on the x-axis, so it must be a sine. All right? That's how I would do that. For this one, 3 petals, so it has to be a 3 theta. Can't be a 4 theta. Okay? There is a petal on the y-axis, but not the x-axis, so it cannot be a cosine. Has to be the sine. That's what I'll need you to be able to do on a test. Okay? All right, number 3. 3 petals, so definitely a 3 theta. Is it a cosine or a sine? Well, this time there is a petal on the x-axis, so it is a sine. So it is a cosine. And lastly, for this one, how many petals are there? I'm going to start with this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 petals, not 3 petals. I guess I could have just used those choices. So the cosine or a sine. Is there a petal on the positive or on the x-axis? There's not one on the x-axis, so it's not cosine. Has to be sine. And those are the circles and the roses. How to graph those. Tomorrow we'll be doing the cardioids and the limasomes.